Okay, we're going to change standard form to vertex form for a quadratic. The way to do that, so you have y equals x squared minus 6x plus 3, for example. What we're going to do first is move the constant to the left-hand side. I'm going to subtract 3. Okay. So you have y minus 3 equals x squared minus 6x. Your next step is going to be to look at this number. When we come to the margin, take half of it. And then we're going to square that value. Okay? So it seems like kind of a random step, but we'll see its relevance in a minute. So take this number, half, then square it. And it's this that we want to add to both sides of the equation. Matter of fact, I'm going to color code here to help you. I'll make this red here. I'm going to add that number, that 9, to both sides of the equation. Okay. Which is perfectly legal because you can do wherever you want as long as you do it to both sides. So we're going to simplify this to y plus 6. And this process actually forces this to factor in a certain way. It factors so that the two numbers that multiply to 9 that add to negative 6 are actually the same number twice. Negative 3 and negative 3. Negative 3 times negative 3 is 9. Negative 3 plus negative 3 is negative 6. So what I can do is write it like this. As this is the way I want to write it. Now note that this is the same thing. Erase this temporarily. The same thing as this, but since it's the same thing twice, I can just say x minus 3 squared. That's the reason that 9 is completing the square, because we have forced it to this process, which can be explained. It would take a minute to explain why, but this process does force it to factor the same thing twice. Matter of fact, we'll go ahead and color code again here. This number actually always shows up in this fashion. And you can use that as a shortcut. You know that whatever half of this is will always show back up here. Your final step is to move the 6 back. So this is vertex form. Standard form has no parentheses, vertex form does. And for this particular problem, it's just a coincidence that both happen to have a 6 and 3, and that's usually not going to happen. From a vertex here, which is either the maximum or minimum of the parabola, as later we'll see when we graph, you're going to change your sign on the inside, but you're not going to change the sign on the outside. So your vertex would be 3, negative 6. And again, another video explained the relevance of that. So pause if you need to watch that again, or if you just need to study that. I'm going to do one more example. I'll keep these examples somewhat mild, as if this were an odd number, it would make a fraction. When you took half of it, it would complicate this some. So I'm going to keep these some of the easier examples. Doesn't really matter what this number is, we'll just say 30. So we'll go through that process again. We'll move the 30 over here. I'll take half of this number and square it. I'm going to add that to both sides. combine two numbers that multiply give you 49 and add give you 14. That would be 7 and 7. And remember, you don't even have to think about that. This number always shows up here. Then we'll move the 79 back. The vertex here, which will be explained in a future video, is -7, -79. It does get more complicated if this is odd or if this is not 1, and even more complicated still, both of those conditions were true. But for now, we'll leave it in simple examples just to get you used to the process, changing from standard form to vertex form of the parabola.